Icse class 10 students, ನಮಸ್ಕಾರ ಸ್ಥಿತಿಗೆ ಬನ್ನಿ. ಇಷ್ಟ ದೇವತೆಗೆ ಗುರು ಹಿರಿಯರಿಗೆ ಪ್ರಾರ್ಥನೆ ಸಲ್ಲಿಸಿ ಇಂದಿನ ಎಲ್ಲ ಅಭ್ಯಾಸಗಳನ್ನು ಏಕಾಗ್ರಚಿತ್ತದಿಂದ ಶಾಂತ ಮನಸ್ಸಿನಿಂದ ಮಾಡಿ ಮುಗಿಸುವ ಶಕ್ತಿಯನ್ನು ಕೊಡಲು, ಕಲಿತ ವಿಷಯಗಳನ್ನು ಜ್ಞಾಪಕದಲ್ಲಿಟ್ಟುಕೊಳ್ಳುವ ಶಕ್ತಿಯನ್ನು ಕೊಡಲು, ಜ್ಞಾಪಕದಲ್ಲಿರುವ ವಿಷಯಗಳನ್ನು ಪರೀಕ್ಷೆಯಲ್ಲಿ ಸರಿಯಾಗಿ ಬರೆಯುವ ಬುದ್ಧಿಶಕ್ತಿಯನ್ನು ಕೊಡಲು ಇಷ್ಟ ದೇವತೆಗೆ ಗುರು ಹಿರಿಯರಿಗೆ ಕುಲದೇವರಿಗೆ ಪ್ರಾರ್ಥನೆ ಸಲ್ಲಿಸಿ. ಟೇಕ್ ಡೀಪ್ ಬ್ರೆತ್ಸ್. Yes, good evening, my dear students. Yes, welcome Pratham. I want more and more students from classic schools to join. Come on live. You complete your all homework or tuitions. Then join me at 9:25, 20 or 20 because I will be leaving the 9:15. 10 minutes I require to refresh myself. Short break. I will start just 40 minutes. These 40 minutes, I will promise you, I will make it very meaningful, right? And you can feel the difference slowly. I will send you assignments also, right? Already I have sent a trigonometric identities assignment, you solve it. And I will send a topic-wise assignment that is written, and I will upload in Vedium's app the MCQs for a time-based quiz, time-based multiple choice question. That will improve your competitive mind slowly. Download Vedium's app first, start mind maths learning, right? Then you will take the course. Started learning the periodic table, development and the origin of the periodic table. So the periodic table development took place in the last class. We studied the first contribution was done by Deverener by his law of triads. It was failed because all elements could not form triads. Then came Newland's law of octaves, an English physicist, chemist, and the most famous table was Mendeleev's periodic table. We studied in the 9th standard, and it was the most successful. In 1869 he found it. At the same time, Newland also announced, but Newland's table was not accepted, but Mendeleev's table was widely accepted. Later in 1913, so modern periodic table, Moseley's periodic table, Moseley periodic table, Moseley discovered atomic number in 1913. By the time the electrons were discovered, protons were discovered, and the table was developed by Niels Bohr. Therefore we call Niels Bohr, whatever periodic table you have now is called as long form of modern periodic table. Long form of modern periodic table. Modern periodic table. So what are the main features of the long form of the periodic table? We try to understand. Right? So the modern periodic table has got totally based on atomic number. Just recall, it is totally based on atomic number. Atomic number, every element, if you see the atomic number of some of the elements, if I take example, so what is the atomic number of hydrogen is 1. How do you write the electronic configuration of it? This is nucleus, this is K cell. In K cell there is 1 electron. And helium will have atomic number 2. Atomic number 2 means in the K cell only it will have 2 electrons. Lithium, atomic number 3, right? So like this atomic numbers, electronic configuration can be written. Then next electron will enter into what? Lithium, atomic number 3. How do you write it as? 2, right? K cell can accommodate maximum 2 electrons. Net electrons will enter into L cell. It will have 1 atomic number of lithium, right? The atomic number of beryllium is 4. How do you write the electronic configuration? 2, 2. Atomic number of boron is 5. How do you write it as? 2, 2, 1. That enters into what? So this particular electronic configuration based on electronic means what is electronic configuration? Electronic configuration is the distribution of electrons in different cells and subcells. This modern periodic table is based on, right, the distribution of electron, and if you draw the shape of it, I will show some elements, and the vertical columns instead of Roman they were named as periodic table, modern periodic table, long form of the periodic table, and the horizontal rows were called as periods. Totally there are 7 periods. This particular period is called as period number. This is hydrogen with atomic number 1. And in the same period you have got second period, third period, you have fourth period, you have fifth period, you have sixth period, you have seventh period. Then second element was helium. Helium directly taken to the right. Next, atomic number 2. Atomic number 3 is lithium. Fill in the blanks. Try to draw the diagram. Open the notebook. Some elements will write so that you can understand the modern periodic table. This group is called as first group. They were numbered continuously. Then comes second group, starts from atomic number 4. What is the element with atomic number 4 is beryllium. And this is second group, right? This particular second group will continue like this. You know that the element atomic number 5 goes to the extreme right. There is a sudden jump here. Why that jump occurs, I will tell you. Then after 10 you will get below lithium there is sodium. In the first group you have sodium, potassium, rubidium, cesium, francium. Don't look at it, you draw on your own. Don't look at the printed, you try to fill in the blanks. That is the best way of learning periodic table. Atomic number 12 will be magnesium. Again sudden jump. Then comes atomic number of potassium is 19. Then you have 20 calcium. Again there is a jump. Then comes right 36, 20. After 20 here again 10 groups are introduced in between. Look at the diagram. 10 elements are in between. You can observe and take the paper, draw the diagram. You can understand periodic table, because to learn periodic properties you must have detailed understanding of the modern long form of the periodic table. Here there are 10 groups. Why there are 10 groups? Why they are classified? Everything I will explain you. Make 10 groups. 1, you continue. This line also. This line also. Horizontal rows are called as periods. And here you get the element number 21. This is group number 3. This is group number, I will write group number 2 here. Here you have 3, third group. Third group starts here. Then they, according to the modern periodic, 10 lines you draw. 1, 2, 3. Take the pen and the paper and draw the periodic table. You will understand better. Instead of looking at the periodic table printed matter, useless. Your knowledge will not improve. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Atomic number 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. After that, new block introduces. You will have the jump that is taking place here. Here, there are 6 groups. This is one set. First and second group will form one block. Third, fourth, fifth group, sixth group, seventh group, eighth group, ninth group, 10th group, 11th group, 12th group. From 13th group, another block starts. I will talk about it now. Another block starts. You will be learning about it in 11th standard in detail. You make a 6 now. After 12, this is 13, 14, 15th group. There are totally 18 groups in the modern periodic table. 16th group, 17th group. Then you have 18th group. So 18th group, on the top you have parallel to hydrogen, there is atomic number 2, helium. Now fill in the blanks. Atomic number 3 comes here, 4 comes here, 5 boron comes here. Boron. 6 carbon. This entire family is called as boron family. The head of the family is carbon. It is called as carbon group. Continue. Atomic number 7 is a nitrogen. Atomic number 8 is oxygen. Atomic number 9 is fluorine. 10 is neon. Now observe how the blanks are filled. This is a modern periodic table. I want you to understand the structure of the modern periodic table today. First, you recall how the modern periodic table is arranged. Then third period, these are horizontal rows are called as periods. Remember, the same name given by the vertical columns are called as groups. Vertical columns are called as groups. How many groups are present in the periodic table? You can easily say now 17, 18. Vertical columns are called as groups. Totally how many groups are there? Right? Therefore, what is the periodic table? What is the periodic table? Periodic table is defined as the tabular arrangement of elements in horizontal rows called as periods and vertical columns called as groups, showing regular gradation in their properties, physical and chemical properties, regular gradation in their physical properties and chemical properties. Next one is 13. There is a jump here. 13. This 13th element, 14th element, you just try to recall at least up to 30, 17, 18. 13th element is aluminum. 14th is silicon. 15th element phosphorus. 16th element sulfur. 17th element chlorine. 18th element argon. The elements of the group 18 are called as noble gases. And now continue. Fourth period. First period is a very short period of only 2 elements. Second period is a short period. We can call this first period as very short period. And the second period as a short period containing how many elements? 6 elements. 8 elements. 2 plus 6, 8 elements. And the third period is also a short period of how many elements? 8 elements. First period is a very short elements containing 2 elements starting from hydrogen, helium. Second period is a short period of 8 elements starting from lithium atomic number 3 up to neon atomic number 10. 6 plus 2, 8. Third period is also a short period of 8 elements starting from sodium 11 up to argon 18. And from the fourth period is considered as a long period because it contains here 2, there 6. These 6 elements form one group. and these 10 elements form one group. These are called as the transition elements. Better you draw the diagram. Transition elements. And here these are called as representative elements. First and second group elements are called as representative elements. Elements from 13 to 18 are also called as representative elements. Have the details of the table. Yes, sir. Today chemistry class. Yes. One day chemistry, right? Monday chemistry, Wednesday chemistry. Fill the elements. Aditya. Okay. Hi. Welcome. Okay. Group 1 elements are called as very good. They are called as alkali metals. I will talk about it now. Classification of the elements. Now check whether it is more visible. Okay. Calcium, atomic number 21. Can anyone of you tell me the atomic number 21 without looking at the table? Atomic number 21. Atomic number 21 is scandium, Sc, scandium, 22 titanium, 23 vanadium, 23 chromium, symbol Cr, 25 manganese, Mn, 26. Yes, what is 26? Iron, 27 cobalt, 28 nickel, 29 copper, 30 zinc, 31, 32, 33, 34, 35, 36. Try to fill. Take 1 or 2 minutes. Try to fill the elements. Fill the elements. After zinc, what you have? After zinc, you will get gallium. Actually, Mendeleev recognized it as eka-aluminium and assumed it. After that, it is proved to be gallium. Gallium is such an element which melts in the hand only. Its melting point is very, very low. Then comes germanium. Silicon and germanium have got semiconducting properties. Germanium. What is atomic number 33? Arsenic. And after sulfur, you have atomic number 34. Selenium, bromine, and krypton. Clear? It is a long period of how many elements? Long period of 18 elements. Entire 18 groups are filled here now. Then comes atomic number 37, rubidium. Atomic number 38 is a strontium group, barium and radium. Element with atomic number 39, 40, 41, 42. Second, this is called as fourth group is called as first transition series because the transition elements from scandium atomic number 21 to zinc atomic number 30 are called as the transition elements. Why they are called so? They are called so because these particular group 1 elements and group 2 elements are pure metals, and from 13 to 18 elements are non-metals. and these elements in between, they show transition from metallic property to non-metallic property. Same periodic properties we are going to study in this chapter. They show transition, therefore they are called as a transition elements. Transition means they show transition from metallic. Group 1 elements are called as except hydrogen, exceptionally placed. That was one of the drawback of all periodic table. One of the drawback of Mendeleev periodic table was also hydrogen. Hydrogen is a non-metal. Being a non-metal, all non-metals should be there present on the right side. Clear? From this boron, if I draw a line, zigzag line, observe here. I will show it with a red color. You can observe this zigzag line. Observe this zigzag line. Are you getting me? So the elements on the right side of this zigzag line are all pure non-metals, and the left side are all metals. More than 85% of elements, total 118 elements are there. All 118 elements, 118 elements, 118 elements are filled now, completely filled, right? So these elements on the right side of this zigzag line, can you observe this zigzag line? You can see it in the periodic table also. In the periodic table also, you can observe this zigzag line. On the right side of the zigzag line, only up to 14 to 15 elements are non-metals. Remaining all of them are metals only. 42, go on filling at least first element, last element, selected elements. 43, 44, I will not go on filling all of them, takes a lot of time. 46, 47, 48, 49, 50, 51, 52, 53, 54. I will write only selected elements. The element with atomic number 39 is yttrium. Why? It ends at below copper there is silver, below zinc there is gold, there is silver, below that you have gold, here you have cadmium, 48, and the last one is xenon. I will not write all elements, it takes a lot of time. And this is called as a second transition period. It is also a long period of how many elements? 18 elements. From yttrium atomic number 39 to cadmium atomic number 48 is called as second transition series. Means transition element second series starts. At least you remember first element and the last element. Need not by heart all of them. 39 to 48. Right? One of the student of 6th standard, I will show you the video in the next period. She reproduced all 118 elements at one stretch. Okay, you can. I will hear you in the same class. Next class, I will show you. Yttrium to cadmium atomic number 18. Then comes 55, the sixth period is cesium, 56 is barium, 57, you observe carefully here. 57th element in the periodic table is a lanthanum. Observe here. From this lanthanum, the 58th element is cut from the main table and placed separately at the bottom. You can see there are 14 groups in it. They are cut from the main table. In the long form of the periodic table, there are two series. Very important. You can make 14 boxes here. First, have a look at it. After lanthanum, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Let me rub the remaining part of it. Observe. I will rub this. How many boxes are here? After that, you have 58. This element is cerium. You can continue 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71. Check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And cerium, the element with atomic number 58 is cerium. Up to 71 is lutetium, Lu. These 14 elements are cut from the main table. They are placed separately at the bottom. This particular series is called as inner transition elements. Inner transition elements. Inner transition elements. And the first series, as it is cut from the lanthanum, they are called as lanthanides. What they are called as? Lanthanides. This is the first series from, remember, first and the last. Cerium atomic number 58 to lutetium atomic number 71. Therefore, the sixth period is a very long period. Very long period of how many elements? It will continue. 71, 72 will continue here. 73, 74, 75, 76, 77, 78. Gold has got 79, 80, 81, 82, 83, 84, 85, 86. Radon. Are you getting me? And after that, 86. You can get 87 is francium. It is radioactive. Even radium is radioactive. Discovered by Madame Curie and Pierre Curie. Radium, radioactive. 88. Then comes 89. 89 is actinium. AC. I'll put a double star here. After actinium, atomic number 90, thorium is cut from the main table. Means totally 18 plus 14. 18 plus 14. If you add, you will get 32 elements. 32 elements, therefore it is a very long period. Long periods will have 18 elements. Short period will have 8 elements. Very short period have 2 elements. So these two will have thorium 90, 91, 92, 93, 94, 95, 95, 96, 97, 98, 99, 100, 101, 102, 103. This last element 103, you can check it. It is called as lawrencium, Lr. Lawrencium. After 103, here it continues 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118. All 118 elements are filled already. And this 72 elements is called as hafnium. Again starts the transition series. And it will continue up to mercury. 80 is mercury. Right? And radon. And after 103, the 104, the element with atomic number 104 is Rutherfordium. In the honor of Rutherford, sir, it is named in the honor of Rutherford. It is called as Rutherfordium. There are very interesting elements. From thorium atomic number 90 to lawrencium atomic number 103 is called as the second series cut from the main table after actinium. Therefore, this series is called as actinide series. I am giving more details about the modern periodic table. Are you getting me? And there are very interesting elements I want to show you. Atomic number 92 is uranium. Atomic number 93 is neptunium. Atomic number 94 is plutonium. They are named in the honor of outer planets. Uranium, Uranus, Neptune, Pluto, outer planets. And some of the elements, element with atomic number 95. AM stands for Americium, America. You can remember some of the interesting names. And in the honor of Madame Curie, element with atomic number 96 is named as curium. And the element with atomic number 99 is named in the honor of Einstein, Einsteinium. Element with atomic number 100 is named in the honor of Fermi, who worked on thermodynamics, fermium. Are you getting me? And very interesting names. Atomic number 107 is named in the honor of Niels Bohr, who constructed this table called as borium, BH. Some interesting names. Right? So they are after element with atomic number 90. Most of the elements are naturally occurring elements are up to 90 only. After 90, the elements are obtained during research. Right? So all the 118 elements are named, and this 118 elements is OZ. Organism. Like this, the periodic table is classified, all the 118 elements are classified into blocks here. This particular block is called as S block. I will talk in detail in the next class. And this particular block of 6 group is called as P block. I will teach you briefly why they are called like that. The middle one is called as a D block. And the following, these lanthanides and actinides are called as F block. This particular classification is based on electronic configuration. How the electronic configuration and this periodic tables are related, we'll see in the next class. You have this periodic table with you. On your own, you draw the periodic table. One 6th standard student from Tumkur, who is the daughter of our Vedim's app developer for Mind Maths, reproduced all 118 elements in 2 minutes 20 seconds. In the live stream, I will show you in the next period. Okay, we will learn more things in the next class. So tomorrow you have mathematics combined class between 8:30 to 9:30 till trigonometry is completed. Icse, I will put join the WhatsApp group. I will put the timing also. Even it will be present in my status. You can save my number 979731571044. In my WhatsApp number it is. In the WhatsApp status, I will put the timing also, daily timing, and even in your WhatsApp group of ICSE, separate ICSE, I will send assignments on periodic table today. Try to answer them. Okay? By the time we meet in the next class. This Saturday, Sunday, there will be no class because I will be out of station, right? Saturday, Sunday. After that, I will start next week. Tomorrow will be the last period of this week. Then I will give some assignment to you. Already I have given you assignments. Similarly, I will give assignments on these periodic properties. And in 2 days, weekend holidays will be there. I will be out of station on Saturday and Sunday. Otherwise, I will start activity on Saturday and Sunday also. And particularly, classic Dharwad ICSE students, I have made this. You join as many students as possible because I taught you last year. I want to support you at your home at 9:20 to 10:05. Okay? Sleep well. Keep your body and mind fit. Do exercise. Regularly do homework. No fear. Desai sir is here. Bye bye. See you.